Alright, so welcome to the video lecture series on Introduction to Computer Networks. And this is part 2 of our lecture topic on common protocols which are used on the internet. And we will jump to the point from where we left off, which is where we start discussing the DHCP protocol, or the Dynamic Host Configuration Protocol. So the DHCP protocol is a protocol which enables devices which are placed in the network to obtain IP addresses automatically. So whenever there is a new host which is connected to a network, and if there is a DHCP server present on the network, the host will be assigned an IP address automatically. There are also other configuration parameters which could be provided by the DHCP server, which may or may not include, the subnet mask, the default gateway, the DNS server, etc. And the idea is that whenever a DHCP-enabled device is connected to a network, it will immediately broadcast a DHCP message or a DHCP request to find the DHCP server which is present on the internet, on the particular network. And whenever the DHCP server receives the request, it will choose an IP address that is available from a particular range that is configured, and we generally call it a pool. And then, based on the choice, it will assign the address to the requesting device for a particular period of time. We call it a lease period. So there are 4 specific messages in DHCP. First, we call it the DHCP discover message. And initially, when a client is connecting to the network, it does not have an IP address, nor it doesn't have any idea where the DHCP server is located. So therefore, it sends out the discover message, which is an Ethernet broadcast frame. And if you remember, an Ethernet broadcast frame is all ones, or FF 44 for a total of 48 bits, and the LAN broadcasts the DHCP discover message to all possible DHCP servers or all devices which are present on the internet on the particular LAN. So when the DHCP discover message is broadcasted, the DHCP servers are able to receive the discover message and knows that there's a new client which is looking for a new IP address. So all of these servers will send out a DHCP offer. So the DHCP servers receive the broadcast frame and sends out the offer to the client, and that includes the IP address, the mask, lease duration, default gateway, etc., and all of these other parameters in the offer, and sends it out to the client's MAC address. So now the client has initially broadcasted the DHCP discover message, and then it received multiple offers from all possible servers which are located or placed in that network. So now it is the task of the client to basically choose one of these offers. So the DHCP request is the third message in the DHCP protocol, where the client requests the particular offered IP to be assigned by the DHCP server. In this case, the client receives 3 offers from multiple different servers, and then it sends out only one client request with only one of these IPs to only one of the DHCP servers. So it doesn't really matter how many offers you get, it only depends on which specific offer you actually accept or intend on accepting. So you send out a request from the client to that particular DHCP server, and finally the DHCP server responds with an acknowledgement message, or DHCP ACK, where the server confirms and acknowledges the IP address that is assigned to that client, including all the other information. The most important would be the duration of time for which the client can use the particular assigned IP. The next protocol that we'll look at is the Internet Control Message Protocol, in short, ICMP. So the ICMP is a helper protocol that supports IP operations. The Internet Protocol has many different functions, and ICMP allows IP to work flawlessly and allows us to exchange different control messages. The basic format is in the form of queries or in the form of error reporting. So ICMP messages are encapsulated as IP packets, and if you look at the layout, the ICMP message is actually laid out as the payload of an IP packet. And the ICMP message, the format looks something like this, where the first three fields are important. First one is the type, the second one is a code, and the third is the checksum. So the type and code, they work together to imply what kind of ICMP packet this is, and the checksum is basically an integrity check that the ICMP packet has not been modified. So an ICMP query is the basic request response message that exists in pretty much all other network protocols. So an ICMP query starts off with a request that is sent by a host to another router or a host, and in return there is a reply or a send or a response which is sent back to the querying host. So the hosts can send an ICMP request and receive an ICMP reply. And just to give you an example, the type and code fields for some common ICMP query messages are the echo request and echo reply, or the timestamp request and timestamp reply. The echo request is a common example which is generated using the ping command that is used to see if a particular network device is accessible on a given network. So the common ICMP messages, the first one is an echo query, commonly known as a ping, and it can be used by a host to check if a particular network device is alive or is reachable. Next, another kind of query is a timestamp query message, where a device can ask another device for the current time. So the current time might actually be a bit confusing, and in this case the way that the current time is expressed is in milliseconds after midnight universal coordinated time of the particular of the given current day. The third kind of message is an error message. This is there are many different kind of error messages, and these are messages which are sent to a device to report some form of error whenever, most commonly if an IP packet is discarded for some reason. And this is generated not as a request response, but rather generated with respect to an occurrence of an error condition. The most common types of error messages would be destination unreachable. The destination could be a network, a host, a port, or even a protocol that is not supported by a different host that is trying to be reached. There could be redirection errors, time exceeded, or a parameter problem with any packet that is being sent out. So for example, if host A sends out a packet to host B, and if this link is broken, then the router can send an ICMP error message saying that the destination is unreachable. In this particular case, it would be a host destination unreachable message.